What is the tyranny of the rocket equation for payload? Imagine trying to lift a heavy box with a balloon. The heavier the box, the more air you need to fill the balloon so it can lift it. Now, think about rockets trying to do the same thing but with fuel instead of air. That's the core idea behind the tyranny of the rocket equation. This phrase describes a fundamental problem in rocket science. When you want to carry more payload, you need more fuel to lift that extra weight. But adding fuel makes the rocket heavier, which then needs even more fuel to lift that added weight. It's a cycle that gets worse the bigger your payload gets. The rocket equation, created by Konstantin Tsiolkovsky, shows that the speed a rocket can reach depends on the ratio of its starting weight to its final weight after burning fuel. Because fuel itself has weight, the more fuel you carry, the more fuel you need to carry that fuel. This means that increasing payload size requires exponentially more fuel. Most rockets are built with multiple stages. Each stage has its own engines and fuel, and once it runs out of fuel, it is jettisoned. This helps reduce the weight the remaining stages need to lift. Without staging, the limits of the rocket equation would make launching large payloads nearly impossible. This problem also influences how spacecraft are designed. Engineers try to make payloads as light as possible because every extra kilogram of weight means more fuel and a bigger, more expensive rocket. But they also need to keep the payload reliable and safe, so they find a balance. Innovations are being explored to beat this challenge. Some ideas include using parts of the rocket itself as fuel, like a self-consuming structure that reduces structural weight. Others look at building space stations or fuel depots in space to avoid launching everything from Earth, which could ease the fuel burden. The tyranny of the rocket equation explains why launching payloads into orbit is so costly and why space missions often involve complex, multi-stage rockets. It's a fundamental limit that shapes how rockets are built and how space exploration plans are made. In the end, this challenge pushes scientists and engineers to find smarter ways to send more into space without making rockets impossibly large or expensive. It's a puzzle that keeps driving innovation in rocket technology and space travel.